Assalamu alaikum dear students, welcome to the third and last part of chapter 5, Sound Energy. In this part we will focus on the fourth objective in this lesson, which is the sound intensity level at a point. Let us first, as usual, recall some concepts from the previous videos. 1. The sound intensity is the sound power received per unit area placed at a point such that I equal power over 4 pi r squared. 2. The sound intensity at a point is the sound power received per unit area of perpendicular to the direction of propagation of the sound at the given point, such that I equal the power received over the receiver's surface area. 3. For a frequency of 1000 Hz, the standard values are threshold of hearing I0 equal 10 exponent minus 12 watt per meter squared. The threshold of pain is equal to 1 watt per meter squared. Okay guys, before explicate in our objective, an important mathematical function should be introduced for you, which will be used soon, which is the logarithm function, or the log function, which is the inverse of the exponential function and can be obtained by the calculator. As any function, we can list some rules for it, such that log 1 equal to 0, log 10 equal to 1, log 10 power n is equal to n log 10, and since log 10 equal to 1, then n log 10 equal to n. Log a power n is equal to n log a. Log a times b will be log a plus log b, and log a over b will be equal to log a minus log b, and n, if n equal to log a, then a is equal to 10 exponent n. And of course, memorizing these rules is not obliged. As we have previously defined the sound intensity, which explains the decrease in sound when moving away from the source, but this physical quantity seems incapable of explaining the hearing sensation of a person. For example, the operation of two identical loudspeakers connected on the same LFG does not create an auditory sensation that the sound is doubled, even that the sound intensity is doubled. This shows that hearing sensation is not proportional to loudness. On average, for our hearing sensation to double, the sound intensity must increase 10 times. And of course, it depends on each person. For this, physicists have defined another physical quantity related to the sensitivity of the ear called the level of acoustic intensity L, which is equal to 10 log I over I0. I0 is 10 exponent minus 12 watt per meter squared, and I is the sound intensity. L is expressed in decibel, referred to the scientist Alexander Bell. L is measured in sound level meter. Now 3 applications will be solved concerning the previous idea. In the first one, we should determine the corresponding sound intensity level for I equal to I0 and for I equal to 1 watt per meter squared. So for I equal to I0, we can replace I by I0 in the formula that states that L equal 10 log I over I0 to get that log 1, which is equal to 0, to get that L equal to 0 decibel. For I equal to 1 watt per meter squared, we just replace I by 1 and I0 by its value 10 exponent minus 12 to get that L equal to 120 decibel. In the second application, we have a source of sound that produces sound of power P equals 0.1 watt in all directions. First, we should calculate the intensity I of sound received at distance R equal to 10 meter. Then we should show that the sound intensity level at 10 meter is 79 decibel. And third, he asked that what does this level become if 10 sources are emitting sound together. So first, we can calculate the intensity I of the sound by replacing P by its value and S by its value. So I will be equal to 7.9 times 10 exponent minus 5 watt per meter squared as shown in this slide. For the second exercise, we should calculate the sound intensity level using L equal 10 log I over I0, replacing I by the previous value and I0 10 exponent minus 12 to get that L equal to 79 decibel. In the third part, the new intensity is equal 10 times I, which is 10 times 7.9 times 10 exponent minus 5. Then we replace this new I, this new intensity, in L equal 10 log I over I0. I is I prime, as I said, so L prime will be equal to 89 decibel. In the third and the last application, in a place the noise is measured to be 73 decibel. If all sources of noise pollution are supposed to be one source at 5 meters from you, emitting sound power P, first we should calculate the sound intensity of this noise and then to determine the value of P. So for number 1, the sound intensity I is equal to I0 times log L over 10. This formula is derived from the formula of L equal 10 log I over I0. So replacing each variable by its value to get that I equal to 2 times 10 exponent minus 5 watt per meter squared. For number 2, determining P, as we know I equal P over S, so P equal I times S. I is equal to 2 times 10 exponent minus 5. R is equal to 5 meter. Then we will get P equal to 6.28 times 10 exponent minus 3 watt. For here we finish this video. As usual, we will sum up what we took. First, the acoustic power of a transmitter is the energy supplied per unit of time. Second, the sound intensity I is equal to the power emitted by the source over 4 pi r squared. Third, for a frequency of 10 of 1000 Hz, the standard values are as threshold of hearing 10 minus 12 watt per meter squared, threshold of pain 1 watt per meter squared. Fourth, the sound intensity level is given by L equal to 10 log I over I0, and we can derive from it that I equal I0 times 10 power L over 10. Thank you guys for watching this video. For any question, don't hesitate to contact your teacher, and goodbye.